headed in the future in a way that's easy to follow for everyone present here. So let us start with the simple question: what exactly is object detection? In simple terms, it's a computer vision technique that identifies both what objects are in an image and where they are. Unlike image classification, which just tells us this picture contains a car, object detection actually draws boxes around each object: the car, the person, the traffic light, and labels them too. This combination of classification and localization makes it one of the core technologies behind many modern AI systems. So, just a minute. Huh? So, in these two images, we can see that this is a car. It has been bounded by a box here. It has been highlighted, and there is a small label here also. This is a person. This is a bike. In this image, we can say this is a traffic light. This is a truck. This is a bicycle. So all these objects have been detected and they have been classified also. Moving on. Keywords. These are some of the keywords which will help us understand the object detection, the concept of object detection in more greater depth. So, bounding box. Bounding box is the final output where the object is finally highlighted. In this image, you can see these blue boxes highlight the person. So, this is the final output which we are interested in. Whereas the anchor boxes are used as reference to build the bounding boxes. So in this image, we can see there are several anchor boxes which tell us that there might be an object in this box. So by combining these two anchor boxes, we get the final output of the bounding box. Now coming to the metrics, metrics are nothing but the formulas or the metrics that we use to understand the performance of our model. So IOU, that is the intersection over union score, that is the simple overlapping score that is between the ground truth and the output of our model. That is like these boxes, how greater they overlap with the output boxes. So greater the IOU score, the better our model's performance is. Now, and accuracy, it's a straightforward. Accuracy is just how accurately our model predicts the object in the box and how accurately that box is positioned on that box. So, coming to the data, uh, what kind of data is required by an object detection model for its training, and annotation? What are annotations? So these two, I'll be discussing this in detail in the further slides. So moving on, the intuition, how it works. How does object detection work? So here's the basic idea of how object detection works. The system takes an image and passes it through a neural network, typically a convolutional neural network or CNN. Now, CNN is the primary or the most basic neural network which is used for image processing purposes. Then, this network acts like the brains and eyes of the computer. It extracts what this network does is that it extracts patterns, edges, textures, and shapes. And then by analyzing all these attributes, the patterns, the edges, the textures, and the shapes, it then predicts two things. First, what object each region might be in and where it is located. So what does this predict is that what object each region might be in and where it is located. So the final output is the set of bounding boxes with labels like car, dog, or person. So think of it as giving computers the ability to describe a scene visually, not just numerically. So it predicts the object class as well as the location of that object. So moving on, what are the key components of an object detection pipeline? So, image input, feature extraction, bounding box generation, and object classification are the primary components of object detection pipeline. So, now let me walk you through the step by step process of how this pipeline works. So, here's what happens under the hood of most object detection systems. Step one, the image is taken as the input. Step two, a neural network extracts the features, basically the patterns it's learned from the past training data. Step three, The model proposes regions where the objects might be. These are the potential bounding boxes. Step 4, each region is classified. Is it a car? Is it a person? Is it a bat? Is it a ball? Or is it something else? Step 5, finally, we remove duplicates using a process called non-maximum suppression. This is a simple process that in which we only keep the most confident predictions just to have higher accuracy and better, higher efficiency and better accuracy. So this entire process here happens in milliseconds in the modern detector architectures. So after this, we will move on to the data sets part. So data sets provide the foundational data for training and evaluating object detection models, which enable them to learn the visual characteristics and locations of target objects. In the field of AI ML, data plays a very important role because it is the data which provides the ground truth for the model to learn and to predict. So now how do we train such a object detection system? So models learn from massively labeled datasets like the COCO and Pascal VOC datasets, where humans manually annotate thousands of images by drawing boxes and tagging objects. Just like in this image, you all can see, there are several bounding boxes here, and the classes are also mentioned above the boxes: truck, pedestrian, motor, tricycle, etc. So this kind of image is required for training. Now, if we further delve into the part of dataset format, like what kind of data is required for training the object detection model, so we'll talk about the MS COCO, that is JSON file datasets annotation format, which is the most common format used for object detection model training. So as you can see in this slide, there are two images. This is the training image, and in this is the JSON data or the JSON code which is used to describe the objects in this image. So for example, let's talk about this dog, which is represented in this red rectangle box. So in the annotations part, we have the BB box attribute here, and 120, 200, 150, 100 is the X, Y, W, H of this box. X and Y are the X and Y coordinates, and W and H are the width and height of the box. So basically, this BB box tells the model that where the object is located in this entire image. And in this categories attribute, we have the sub-attribute as name and super category, that is the dog and the animal. So the name is dog and the super category is animal. So this tells the model that what kind of object is located in this bounding box. So this is a dog, which is an animal. So this is the kind of data set that we need to provide to an object detection model for the training purpose. Moving forward, we have these popular models with us. So these are some of the most popular object detection models here. So here is the YOLO. YOLO is extremely fast. It processes an entire image in one go, making it perfect for real-time systems like CCTV or autonomous vehicles. Then we have the faster RCNN model, which is more accurate but slower as compared to YOLO. So it's used in applications like medical imaging, where precision matters more than speed. And then we have SSD, that is the single shot multi-box detector, which provides a balance between the two. These models all rely on the same principles, but are optimized for specific needs. Moving on, why it really matters. Real world applications. So why does everything object detection, why we have built so many models? So what are the applications of object detection? Let us delve into that. So object detection is a foundation for so many technologies around us. In self-driving cars like Tesla, it helps identify pedestrians and traffic signs in real time. In healthcare, it detects tumors or abnormalities in X-rays or MRI scans. In retail, it's used for shelf monitoring and customer analytics. Even our smartphones rely on it, for example, in face unlock and apps like Google Photos. So whether it's saving lives, improving convenience, or driving automation, object detection quietly powers much of today's intelligence systems. So we saw the applications of object detection. Now let us see how object detection itself has evolved over the time period. So first, object detection concepts were visualized or patented in 2001, and the primary concept on which object detection worked was Hawk plus SVM, which were the rule-based models in which engineers had to manually design what features to look for. They had to make rules for what features they had to search for. Then came the deep learning revolution with models like RCNN, faster RCNN, which automated the feature learning. Soon, real-time detectors like the YOLO here, the faster RCNN, YOLO version 3, version 4. So soon, real-time detectors like YOLO, you only look once, and SSD, that is the single shot multi-box detector, changed the game, allowing live detection in video streams. And now we do have DETR, that is the transformer based approaches, which are an extremely advanced level of object detection architectures. So they handle very complex scenes with higher accuracy. So this complete journey has been all about improving the speed and accuracy of object detection. So moving on, as any technology is prone to challenges, object detection is no exception here. So these are some of the challenges which I'll explain. Uh, One big challenge is the occlusion, when one object overlaps another, making the detection harder. Another challenge is lighting and angle variation, where an object looks very different at night, in the morning, or in the afternoon, or from a completely new perspective. Then we also have smaller blurry objects which are tough to identify accurately. Then comes the ethical concerns of object detection. So, especially around the surveillance and privacy. So, while the technology is powerful, responsible use is also equally important. So, this is all. Thank you all for listening. I hope this gave you a clear understanding of what object detection is and why it's such an exciting area in AI. I'd love to take any questions, whether you want to know more about the algorithms, the data sets, or the real world applications. So, if any questions, feel free to ask. Okay, I guess we can move on. Over to you, Neha ma'am.
Thank you so much, Varun. That was a really good and informative session, and I'm sure everyone enjoyed it. So, we'll return after a short break where Aishwarya will take us into BSA, a very simple annotator. After learning about object detection, we'll see how this data is really made collaborative.